Going into topic 3 of chapter 8, we're going to study solutions of the quadratic equation a little bit. And as we look at the quadratic formula here, there's an interesting thing as we look at what we find under the radical sign. B squared minus 4ac. This has a unique property to tell you things about the quadratic equation. Now, what I have in blue there, what is under the radical sign, is called the discriminant. Now, if we look at what values we get under the radical sign, if under the radical sign it's greater than 0, if this, let's say, is a 4, let's say that this discriminant comes out to be a 4, then this is going to be a perfect square, and you're going to get, as a result, 2 real numbers that are rational. Now, if under the radical sign, the discriminant is, let's say, 5 instead of 4, we can put the radical sign over them, then again it's going to be 2 real numbers, but they will be irrational because of the radical 5. Now, if as you do the discriminant becomes a 0, the square root of the discriminant is 0, then plus or minus 0, you're only going to get one real answer. Now, if when you determine what the discriminant is, it becomes a negative number under the radical sign, like negative 5 or any of those, then instead of getting real numbers, you get imaginary numbers. Now, if you were to look at your textbook, they actually have a graph of each one of these. And for this first one, the graph looks like this. That is, you're going to get 2 real number solutions. If the discriminant is 0, then the parabola looks like so. And I didn't quite get there, but it should touch the x-axis in only one place. That gives you one real number solution. But if it's negative, then the graph looks like this. It never reaches the x-axis. So, a little background on what we're looking for and how do we do it. Well, for number 1, we put what we have here as b squared, which is going to be 64, and then we say negative 4 times a, which is 5, times c, which is 3, and we get 15 times 4 is 60, 64 minus 60 is 4. So we actually get then the square root of 4. It's going to be 2 rational numbers. solution because 4 is a perfect square, and as we mentioned, if it is a perfect square, they're rational numbers. If this ended up being a 5, there would be 2 irrational solutions. Real numbers, but irrational. All right, let's do this one. So we're going to square 40. I'm going to have to use my calculator. So 40 squared is 1600, and then a negative 4 times 16 times 25 is 1600. So in this case, our discriminant is a 0. Square root of 0 is 0, so you're only going to get one real number solution. That's this one. Oh, I didn't even know that. Okay, let's go on to this one now. We're going to say this is 47. How about 49? 7 squared is 49 minus 4a, which is 3, times 5. So this is 15 times 4 is a negative. We have 49 minus 60. So we're going to get a negative 11 under the radical sign. Our discriminant is a negative 11. So here we're going to get 2 imaginary or complex solutions that are irrational. Okay, so there's the background. This is sort of an easy thing to do. I did want you to understand the significance then of the discriminant and what it can give you. Okay, this next part I think is sort of interesting too. I guess everything's interesting for me. Let's go and say, what are we going to do here? Well, I think we did some of these a little bit in the past. Is now they're giving us the answers to what the quadratic equation results in, their solutions. But they're wondering if we have the answers, can we figure out what the original equations were? And there is a strategy. And the thing is, we just work backwards from what we have. Now, generally, what we did is we solved these by putting them in a factored form. So there's sort of our basic factored form standard there. And we have a 4. So that 4 goes there. And we said it was the opposite sign. So it's going to be a negative 4, and this is an x. Now we knew there was an x there, and we ended up with this as our answer. Well, remember, this was the denominator that we divided this by. So this is going to be a plus 2, opposite sign, and the 3 goes there. So we have taken it back a step from where we're going. Now what do? Well, we FOIL this. This is going to be 3x squared. Now this is a positive 2. This is a negative 12, which gives us then a negative 10x minus 8. And we did it backwards. So we started with the answers. We put it into the framework of factoring. We FOIL this, and there's our equation for this one. All right, we're going to use that same technique for letter B. Two sets of parentheses equals 0. Now we know there's an x there and an x there. And if you notice, these are sort of the results of conjugates. They're opposite signs, so it'll be x for this first one minus 4i, and this will be x plus 4i. Now, when we do the FOIL, notice it will result in the difference of perfect squares. We're going to get x squared minus 16i squared. But what did we say I squared was? A negative 1. So this becomes x squared plus 16 equals 0. Now, you should note here that in the past, we always said that you can't factor the sum of squares. You can only factor the difference of squares. But now that we've introduced imaginary numbers, we know that the sum of perfect squares will now factor, but they're going to be imaginary numbers. All right, using our same technique. So once you break the ice of the technique here, I think things get a little easier for you. Opposite signs. Opposite signs. And again, these are conjugates, so there's no middle term. So we're going to go x squared. Now, let me put the 4 there too. That makes it a little bit better. Negative 4 times positive 4 is a negative 16. We're just doing this in pieces. Square root of 5 times the square root of 5 is 5. And then to finish this up, we just do this multiplication, and we get x squared minus 80 equals 0. Wow. Now, those of you going into pre-calculus and later calculus, you'll be asked to do things like this, factor that, because normally this is not factorable. But if you keep in mind, radicals can be introduced, and this type of thing, it works. Okay, let's go on to this next one here, letter D. In fact, I can put letters there. A, B, C. And you want to have these in your notes, of course. So for this one, we're going to need 3. And we know there's going to be an X, an X, and an X, and then opposite signs. Plus 3, minus 1, minus 5. So here we're going to FOIL. X squared plus 2x minus 3, and then multiply it by this. Plus 15 minus 10x minus x squared, 5x squared. This is a negative 3x plus 2x squared x to the third. And it's x to the third minus 3x squared minus 13x plus 15 equals 0. So we have gone from the answers by working backwards to our original equation. And now for this last one, letter E. Now, when you have a 0, that's just going to be an x there, like so. And we have opposite signs. This will be a plus 4. This will be a plus 2. So we FOIL this, x squared plus 6x plus 8. Then we distribute the x cubed plus 6x squared plus 8x equals 0. Okay, so just under 17 minutes. Now, once again, the textbook is there. There's additional exercises there available for you. And you'll be doing your practice. And any questions that you have, bring into lab. Okay, we'll wrap this up.